Hey everybody, I'm Phil. I'm super excited to talk to you today about connecting temporal apps across isolated namespaces with Nexus. And you might ask, like, why do I need multiple namespaces? Why can't I just use a single large monolithic namespace that all my teams and workers can use? And you can, it actually works pretty good. But when that page rolls in at 3 a.m., it sure is nice to have that incident isolated to just your team. Or if you have sensitive workflow state, like PCI data, you might want to secure that in a separate namespace with a separate encryption key. So in an ideal world, each team can have their own namespace for improved security, modularity, troubleshooting, and fault isolation. And I'm joined today by Pedro Albuquerque and Juan Agustín Moyano from Miro to talk through their use of temporal and Nexus for cross-region data orchestration. So if you look at the typical services in an app, it might look something like this. But the question becomes, how do they communicate? And more importantly, does it support durable execution in the way that we want? And in the past, you might have used like child workflows or activity wrappers that target a remote namespace directly, using like an MTLS client cert and the temporal client. But that's going to give you carte blanche access to that billing namespace. And the billing team might not be so cool with that, right? They might want to expose a smaller surface area that exposes a clean service contract for the order team to use. And so both of these approaches have notable limitations. In general, workflow to workflow direct integrations are a leaky abstraction. The caller has to know the target namespace, the target task queue, all the workflow policy options, conflict policy, reuse policy. And then somehow the order team is responsible for maintaining workflow ID uniqueness in the shipment namespace, which is something the caller shouldn't have to know, and something the provider definitely doesn't want the caller messing with. Also in temporal cloud, child workflows have to run in the same big monolithic namespace, meaning that everybody's got access to everything, and the blast radius for the workers are not isolated. Activity wrappers are just a lot of boilerplate code that you have to write and then run every caller namespace. And you have to spin up these bespoke APIs, or in more advanced scenarios where you have longer running workflows, you basically need another activity wrapper, in the billing namespace that's gonna signal back to the caller workflow, or you're having to pull for a long time, from that activity wrapper, which is definitely not ideal. But even after you do all of that, do you get the fully integrated observability? And does it enable durable execution in the way we want? With execution debugging, with support for synchronous and asynchronous operations, and with reliable state-based execution. So now with Nexus, you get a fully integrated temporal experience where you can use the temporal SDK to spin up Nexus handlers in your temporal workers and expose a clean service contract for other teams to use via Nexus endpoint, which is a reverse proxy for your Nexus services. And you can use the Nexus registry to dynamically create these Nexus endpoints, and in the open source, that registry is scoped to a cluster. And in Temporal Cloud, that's scoped to your entire account across all your users and namespaces. And since we use the temporal queue-based worker architecture, you get automatic load balancing for free. We support automatic retries with exponential backoff, with circuit breaking and rate limiting, and fully integrated observability and execution debugging. And in Temporal Cloud, we also have a global MTLS secured Envoy mesh that connects all of your namespaces within your account together. And this enables us to route Nexus requests within and across regions, and even across clouds, as we're about to see in this demo. Temporal Cloud also provides fully integrated access control, so you can say, oh, the order team is the only caller namespace that can use this billing Nexus endpoint and all the services on it. And so you can configure that access control policy, which we'll see here in a minute, on the Nexus endpoint definition. So with that, let's pop over to our OMS demo. This is an order management system reference application, and it's available on GitHub, so you can go and check it out. And it encompasses a lot of the best practices for using temporal. And we've taken this and ported it to use Nexus instead of using child workflows and activity wrappers. So we can come in here, and we have some pre-canned orders for this demo. Vans Old School Sneakers, I love those, so I'm gonna grab some of those and go ahead and put that order in. The order was booked, the payment was successful, but what happened in Temporal? So if we go into the Temporal UI, we can see the Nexus registry. And here we have 3 Nexus endpoints, and these Nexus endpoints are reverse proxies for your Nexus services. And if we crack open the billing endpoint, we can see that just like a reverse proxy that supports multiple upstream targets, today we support a single upstream target namespace and task queue that those Nexus requests will get routed to. And you can define a description for your service with Markdown, with basically information about who should I contact to get access to use this at runtime, information about what operations are available and their types, or a link to a GitHub repo that might have a protodef or a JSON schema. And then at the bottom, you can see that we have a built-in access control policy of allowed caller namespaces that says that only the order namespace is allowed to use the Nexus services on this billing endpoint. And then if we pop over to look at the namespaces, we have 2. One is AWS EU West 2 here in London, and then the billing namespace is in GCP Europe West 3, which is in Frankfurt. And so if we crack open the order namespace, we can see the order workflow is running, and we're gonna see some new things in here. So the Nexus operation, just like an activity, has a scheduled, started, and completed state. And you can see the service and the operation that was invoked, the input, the schedule to close timeout that the caller can specify, as well as a new auto-wired bidirectional link that'll take us directly to the underlying workflow that backs our Nexus operation. And in this case, this is an asynchronous Nexus operation. We also support synchronous Nexus operations, and that skips just directly from scheduled to completed. But if we click this link, and you'll notice that we're in the AWS EU West 2 namespace up here right now, and this is gonna jump us right over to that underlying handler workflow in the GCP namespace. And we can see some things here. So we see that the workflow completed, the charge was successful, and that Nexus automatically wired a callback from the handler workflow back to the caller's Nexus machinery that will then record that in the caller's workflow history so that it can basically be durably delivered. And if we click this bidirectional link that's going back to the caller workflow, you can see that we're right here. And there's another Nexus operation. And so once the payment's been successful, we're gonna ship that order out, and we can see that the order shipment is pending. Just like an activity has pending activities, we have pending Nexus operations. So a very consistent user experience. And then if we pop into the shipment workflow, we can see that we actually passed in a user-defined callback. So Nexus, unlike child workflows, is peer-to-peer. So you can think of it as siblings, and you can, unlike like a parent and a child workflow in a hierarchy, you can talk back and forth across your namespaces and workflows that way. And that's basically what we've done here. So the order workflow said, hey, go ahead and ship this out to the user, but when you get delivery notifications, when it gets put on the truck, when it hits that distribution center, when it gets delivered out to the customer doorstep, go ahead and call me back, and here's a Nexus endpoint to do that. And that's exactly what happened here. And this is an example of a synchronous operation. And so it's just basically going to be backed by a signal in the order namespace that signals that workflow, but it's doing that via Nexus. So let's get this order shipped out. So here we can see that it's booked. And if we come in as the courier, we just had our cup of coffee. We're in the warehouse, and we're like, let's put this on the truck. And go ahead and put that out there. And then we can see that an additional Nexus operation has been sent. And then one more to get it actually delivered out to the customer doorstep. And then that basically will complete that Nexus callback for the overall Nexus operation backed by that workflow. Will be delivered. We can go back to the order workflow, see that that's all happy, and the workflow is complete. But what actually happened in the code? So we ported this from the kind of the baseline OMS reference app and then swapped out this, activity wrapper and this bespoke API and these child workflows for using Nexus. And now we're running it across 2 separate namespaces in different regions and different clouds. And before, you needed to go and spin up that bespoke API. So you'd put like a, post-charge operation, you'd write a handler func, you got to do some serialization in here and then execute the workflow. And then you got to wait for that workflow to complete. And if it's a long-running workflow, you probably don't want to do this. You probably want to actually let that process asynchronously, and then you would have like another activity that then signaled back to the caller workflow. And that's just a lot of work and moving parts, and you don't need any of that anymore. So with Nexus, you can just say new workflow run operation, specify the name of the operation, charge operation name, the workflow charge, and then you can map the Nexus operation input to the workflow start options. And this helps you encapsulate, the details of what you're using to back that Nexus operation. So you can kind of present a clean service contract, and that provides a facade behind which you can refactor and say, oh, I'm sending a signal today, I'm starting a workflow today, but I can change that, right, without impacting any of the callers. Also, if you're starting it in the same worker process, you can use enable eager start, which will reserve a slot in that same worker process and start the workflow right there while still recording out durable state to temporal. So if that process crashes, it'll still be restarted on another worker. And that's currently in pre-release, but it's been around for a while, so it's pretty stable. And then the other thing to note is that you can start workflows in the same task queue, and that's the default. But you can also run your Nexus worker in a separate task queue with a different worker pool. And then you can start workflows on different task queues in the same namespace with different worker fleets behind them that might have different IAM permissions to different underlying resources and so on. So there's some flexibility in terms of the deployment topology that you can use with Nexus. And you simply new up a Nexus service, register that charge operation, and then go ahead and register that service with the worker. And then the worker is going to be pulling on this task queue here. And if we pop back over to the Nexus endpoint, we can see that that task queue is right here. So effectively, requests come inbound to the billing endpoint. They get routed to the upstream target namespace and task queue. Your worker is polling that billing task queue, and then it will be sync matched in temporal so that it can deliver that right away with low latency. So that's basically the handler experience. And then if we were to go look at how that changes from the order workflow, the caller, here we're just referencing the Nexus endpoint names. So we don't have to know anything about target namespace, target task queue. All of that's abstracted from behind the Nexus endpoint. And so here we're just going to use billing or shipment to communicate. And then before we're using an activity wrapper. And so we were executing the activity wrapper here, and we can just swap that out with a Nexus call. We can use the same input, and we support schedule to close timeout today. We're intentionally keeping the Nexus operation start options small, just to get a better separation of concern between the caller and the handler. And then we're going to be pretty diligent about keeping that as minimal as possible. But we'll be adding additional timeout values to that in the near future. And the other cool thing is that since we don't need that activity wrapper anymore, all of this code goes away because you can invoke Nexus operations directly from your caller workflow. So that's pretty nice. And that's an example of an asynchronous Nexus operation, using the new workflow run operation SDK helper builder function that auto-wires, those bidirectional links and the Nexus callbacks for you automatically. But we also support synchronous operations. And an example of a synchronous operation is here. And so you can see that, it just gets a context in the input. And then you can execute arbitrary code in here. You can also get an initialized temporal client in the same namespace. And then you can use that to signal a workflow, which we saw in the demo, update a workflow, start a new workflow. It's really up to you what you want to do in here. But you only have 10 seconds as measured from the caller's Nexus machinery. So, you can mine the tiniest bit of Bitcoin, but not a whole lot. So, and then calling that looks exactly the same, and registering that looks exactly the same. So very easy to kind of spin up Nexus handlers in your temporal workers, right alongside your existing workflows and activities, just to expose that clean service contract for other teams to use, while keeping your namespace secure, locked down, and not sharing too much. So the other thing we wanted to look at was the invocation of the shipment workflow. And so if we go back over here, this is back in the order workflow. So previously we were saying, oh, we're going to execute a child workflow. And what that meant is that we had to be in the same namespace in Temporal Cloud. So now everybody's got access to everything in that namespace. Not super great. Shipment team's not super happy about that, but it's like, okay. But they're like, oh, we can do Nexus. This is great. So they just swapped that out. They passed this notification callback in for kind of order delivery. We're going to be improving this experience where we might support streams or multi-part operations. We're still working through the details of a more ergonomic experience for user-defined callbacks and delivering notifications, but you can do this today. And then the shipment API just simply added a new workflow run operation and then spun up that Nexus service with just this little block of code here. And so what do we just see? So if we pop back over here, we converted that billing service to Nexus. We ditched our bespoke endpoint and HTTP handler, and we spun up a Nexus endpoint. And you can use the Temporal UI, the CLI, the API, and then in Temporal Cloud, we have Terraform provider support for lifecycle managing your Nexus endpoints. And then we were able to get rid of all that activity wrapper code and swap out the activity call for a Nexus call. And the shipping team, who previously was forced to live in the same namespace as the order team and have no separation of concerns and not have the security that they might want, simply added a Nexus endpoint and handler, and then we swapped out the child workflow for a Nexus call with just a tiny bit of code. So Nexus is now generally available, and it's available both with Go and Java. The Go SDK is GA, the Java SDK is public preview, and it'll be GA later this month. And you can build and use service contracts with whatever you want. So Nexus at the transport layer is very unopinionated. You can pass in anything that the data converter supports. We have a default data converter that supports JSON, serialization, proto, binary, and you can add your own. So Nexus works with all of that. If you're using a codec for encryption, it'll also encrypt those payloads. And even if you're using different encryption keys in different namespaces, we have ways of passing that KMS key ID, for example, in the payload metadata, and that can enable that to work very easily. And so you can run Nexus handlers in your temporal workers, and you can make Nexus calls from caller workflows. And this has all state-based execution, integrated observability, execution debugging like we saw. And it also has some nice properties. So we have at least once execution guarantees up to the schedule to close timeout that we saw earlier, because Nexus has state-based execution, has automatic retries. And so you'll be guaranteed to have that called at least once. And then if you want to upgrade that to exactly once, you can back that Nexus operation with a workflow that has a reuse policy of don't allow duplicates. And so that's a very nice property to have for your Nexus services. And all of this is available both in the open source and in Temporal Cloud. And then in cloud, we also have, like I mentioned, that global MTLS secured Envoy mesh to connect within and across regions in both AWS and GCP, like we just saw in the demo, integrated access control. You can audit changes to the Nexus endpoints with our audit integrations. And if you want to use like an MRN, a multi-region namespace, to go from 3 nines to 4 nines of SLA, you can use that as a Nexus endpoint target namespace. And we provide 4 nines of SLO for everybody, but if you just want that contractual guarantee going to that 4 nines, MRN's a good thing to look at. And so we have a pretty rich roadmap ahead. It's kind of focused in the near term on 3 key areas, kind of broader connectivity Like I mentioned, we support Nexus connectivity today from a caller workflow to a Nexus handler, but we want to make that for non-workflow callers as well. So if you're coming from a non-temporal service or a UI backend or even a bash script with curl, you'd be able to use that Nexus service directly. So that when you build Nexus services backed by temporal workflows and primitives, you can more easily share that with everyone in your organization. That'll be available in two forms. So to start, it'll be available in the Temporal SDK in the client, where you can connect to a caller namespace to basically prove your identity, connecting with MTLS client certs or API keys, and then basically making the calls through that namespace gRPC endpoint for your caller namespace. And that's great, and you can use that in a lot of places. We're gonna add support in the Temporal CLI, so that even from Bash, you'll be able to make and start those Nexus operations, just like you do when you start a workflow from the Temporal CLI. But we also want to provide an HTTP gateway for Nexus. And this will allow anybody to basically make those Nexus calls, even from Postman, from curl directly, and any UI, single page application, and so on. And so we might need non-namespace credentials for that, especially if we're coming from a UI, you might not want to pass an MTLS client cert all the way from the web browser. So, we're looking at passing, of course, the API key on the authorization header, but also something like maybe passing in a JOT token and validating it against a JWKS URL to make sure that it was minted from your IDP, and cracking that open and looking at claims and making authorization decisions based on that. And then with that in place, that really enables broader connectivity across both the open source deployments and temporal cloud. So if you have hybrid deployments, you'll be able to have connectivity across them and to use Nexus across those boundaries. Improved developer experience is another key area of focus. We're rapidly moving to get all SDKs supported for Nexus. We've currently got the Rust core SDK that supports Python, TypeScript, and .NET done. And then we're working on Python and TypeScript right now. .NET will come after that, and then the other SDKs later this year. We're still working on improving the ergonomics to provide kind of like a higher level experience, more helpers, and also a service contract, more opinionated IDL, probably multiple, like a gRPC proto style, Open API, v3, and others. So if you have IDLs that you like to work with, that you're doing code gen with, come find us at the Nexus booth and let us know. We currently have 3 prototypes with gRPC style, with some minor annotations and a Proto-C plugin for doing code gen. So we'd love to get your feedback on that. And then the last category is kind of operating. With multiple callers, multiple tenants, you kind of want to know, who's using your stuff and how much. And hey, I just gave Joe access to the service yesterday, and he decided to run a load test right in the middle of shopping season, right? So I want to understand who do I need to talk to fix that, and ideally trying to fix that before it's a problem with rate limiting on a per caller basis, right? So I can just say, hey, Joe, you got 200 actions per second, and then we're not in a firefighting mode for that. Fine-grained ASI is another thing we hear a lot. So providing authorization both at the service and the operation level. We have one user that basically has put Casbin in their production deployment of Nexus that does kind of a fine-grained ASI there. And enhanced routing rules is another thing. So like I mentioned today, Nexus supports a single upstream target. But ultimately we want to be able to route to multiple upstream targets, either along service boundaries, or if you're debugging a production environment and you want to send one request from production to a worker on a different task queue, on your developer laptop, and routing that by Nexus header. So we're looking at different scenarios we want to support for enhanced routing rules. And so with that, I'm going to hand it over to Pedro from Miro to walk through their use case on cross-region data orchestration. Pedro.
Hi everyone, I'm Pedro, staff engineer on Miro's Knowledge team. I'm here with my colleague Juan, who works alongside me on the same team. Today, We're excited to share how Temporal, and in particular Nexus, helped us solve critical challenges in different segments of our business. We started exploring Temporal around a year ago, looking for a more robust solution to handle our entire storage lifecycle. Even though our team manages and deploys most of our storage infrastructure using Terraform, we found a significant gap when it comes to orchestrating complex workflows. Terraform is great for applying desired state, but when you need continuous observation of the actual state and coordination across multiple resources, Terraform alone starts to struggle. We found ourselves lacking an orchestrator self-healing control plane capable of handling multi-step workflows at scale. Our approach to adoption was intentionally incremental. We started by automating high-impact and time-consuming tasks, such as PG repack for Postgres. Once we saw the benefits of that automation, we expanded its usage to other data management processes, such as backfilling new columns to address evolving query patterns in our sharded Postgres clusters, and also enabling teleport access across our Postgres fleet. Within just a few months, our first service leveraging Temporal was already running successfully in production. This gradual onboarding gave us immediate value and allowed us to validate Temporal's durability, reliability, and scalability on a smaller scale before rolling it out more broadly. Shortly after putting our first Temporal service into production, an urgent need arose to support a sudden increase of customer cross-region data migration requests. Originally, we relied on a large and manually updated spreadsheet to track each request. While it worked for a smaller volume of data and fewer requests, it quickly became complex as demand grew, introducing coordination overheads. We had to tackle this situation and work on a project to streamline this process. Juan is now going to talk more about it.
Thank you, Pedro. Hello, everyone. I would like to share with you a little bit of the cross-region data migration project we implemented at Miro with Temporal. So the goal of the project was to create a platform we can use to move data, customer data, from one region to a different region. And this is very important for our customers that need to comply to their data residency requirements. The problem is very complex. Data is spread across many different services and domain owners, which use different languages and SDKs. And it's a complex problem because the process takes quite long and it's quite a complex orchestration that is needed. And also complexity comes from the fact that regions are completely isolated and we need to orchestrate a very complex process between two isolated regions. So early on when we started developing the platform, the Temporal team suggested us using Nexus as a way to communicate the orchestration between regions. And I'm so happy they did that because Nexus became a very important component of our platform. So let me show you how we use Nexus for this project. So in this very simple diagram, we have two regions, the one that holds the data and the target region where the data needs to be moved. And at Miro, all the regions that we support are identical and there is symmetry on the platform, which is nice because allow us to move data on any direction. Each region has what we call the root workflow, which is the main orchestrator. So if we are moving data from source region to target region, the root workflow running on the source region is the one that takes ownership. And that workflow then uses Nexus to talk to the root workflow, which is running on the target region, and that way orchestrates a global workflow concept, which is quite nice. The nice thing about Nexus is supports all temporal primitives. So this global workflow concept can also deal with signals and updates and queries, which is very, very convenient. So thank you again, Temporal team, for suggesting Nexus. And now I will hand it over back to Pedro. Thank you.
Thank you, Juan. now that we have just covered our cross-region migration architecture, here's an overview of Miro's next steps with Temporal. We want to adopt claim check pattern to keep sensitive and large data out of Temporal Cloud. We also want to invest in safe deploys to validate changes to our workflow code and ensure that we do not experience unexpected non-determinism errors in production when we roll these changes out. As I mentioned earlier, we will integrate Temporal across the entire storage infrastructure lifecycle, from provisioning to data operations and other maintenances. We will also incorporate our production operations tooling for administrative tasks into Temporal workflows to reduce manual effort. We also plan to manage entire workflow sets in each region through one orchestrator. By using Temporal Nexus, we will be able to seamlessly coordinate these geographically distributed and isolated environments. For example, when patching a database, we'll automate updates in non-production environments across each region first. Once those pass, we'll move on to production in each region, ensuring a safe and controlled rollout without manual overhead. And that's it from us. Thank you, Temporal team, for the help during the onboarding process and especially on the Nexus adoption.
Awesome. Thanks, Pedro. So we just saw, Miro's use of Nexus for kind of cross-region and just kind of diving in to see a little bit more how Nexus works and just kind of breaking this down a little bit. So one team says like, oh, hey, I see you're using Temporal and I want to use, your workflows. How can I do that? And, team A is like, well, I don't know. Like, how can we get this clean service contract to basically front all of the temporal primitives that we have, in our namespace? So I said, hey, let's create a Nexus service. Great idea, right? And what is a Nexus service? So a Nexus service is just a named collection of operations, very similar to other, RPC framework type things where you have gRPC with a service and RPC. You have thrift and various other ones, right? And so you can expose temporal primitives like a query, a signal, and update as a Nexus operation. And we saw the code for that earlier. And that can then basically also expose, a workflow as a Nexus operation using the different builder, the new workflow run operation builder. And then registering that service with the temporal worker that's pulling that task queue to serve Nexus requests. Great. So we created a Nexus service, but how do we use it? And yeah, they can't actually call our namespace, and we don't want that for security reasons, right? We want our namespace locked down. If we have sensitive workflow state, we don't want other people having access to that. We want to limit the blast radius. And so, okay, like we're gonna expose a Nexus endpoint that basically will route that traffic, to a target namespace and task queue that our Nexus service is running on. And so we can do that through the UI and to specify, the target namespace, the target task queue, and then the access policy there that just says like which caller namespaces can use the Nexus endpoint. And that's it. And you can do this from the UI, the CLI, API, and Terraform support. And awesome. So the service is available. We've published it to the Nexus registry with the name payments. And that's the only thing that the team B needs to know. And typically you'll do like payments.prod or payments.UAT and so forth. But and then how do we actually use that service? Well, like we saw in the demo, in your caller workflow, you can just use an example here, the Go SDK. The workflow package supports, invoking a Nexus operation. And then you can get the results of that by waiting on the future that is returned back. So how does Nexus actually work under the hood? We've seen kind of what happens from the SDK point of view, like in your worker, from your caller workflow. Well, we currently use Nexus RPC basically between two temporal servers. In Temporal Cloud, this can be across namespace boundaries, across region boundaries, and even across clouds like we saw. And this is designed for arbitrary length operations that can be any amount of time. And the caller experience just says, hey, I want to start this Nexus operation. And then you can either, like register a callback, or you can do long poll wait, short poll wait. And you'll see that we'll be eventually exposing this more directly, like we mentioned, for non-workflow callers via that HTTP gateway. But today within Temporal, it's just between the two, temporal services. And so in Temporal, with Temporal Nexus, logically, you just want to execute a Nexus operation from the caller to the handler. But what actually happens is that that caller workflow is running in a temporal worker, and that temporal worker is going to MTLS authenticate into the gRPC namespace API and do a respond workflow task completed with a command that says schedule Nexus operation with the input that you specified. And that temporal service will durably record that in the caller's workflow history, and then also atomically transfer that to the Nexus machinery, which will do state-based execution to execute that with Nexus RPC on the wire between those two temporal services. And since we're basically operating within and across regions and clouds, we're going to resolve that Nexus endpoint and find out which temporal service we need to talk to. And then the receiving side will resolve that endpoint to get the target namespace and task queue that should be sync matched to a temporal worker who's polling. And then that temporal worker will start the Nexus operation. And this is an example of a synchronous operation, but also async operations are started in the exact same way. And so when you do a sync operation, like querying that workflow, you're going to just go ahead and execute that query from your Nexus operation handler back to the temporal service, and then get the response, send that back through the worker who will respond Nexus task completed, and then that will be sent back synchronously with the same Nexus RPC HTTP post operation to the temporal service caller, who will record that durably. In this case, it's a synchronous operation, so it'll just get reported as that it completed the Nexus operation, and then it'll unblock the future that the caller workflow had been waiting on. So the caller workflow, here we can see, will just show scheduled and completed after that Nexus operation completes. So similarly, for asynchronous operations, it starts in the exact same way to start the operation. And then we're using here the new workflow run operation SDK helper builder function, right, to spin this up. And then that operation handler will do a start workflow. And like we saw, we can either start that with eager start in the same worker process, or we can just start that normally. And we can do it both on the same task queue or a different task queue at our option. And then that will basically show up as, hey, the handler workflow has been started, and we have this Nexus callback registered automatically by the temporal SDK. And it's in the standby state because this underlying handler workflow is not completed yet. And so that will return back an operation token for the Nexus operation that you can use for things like canceling the operation or getting the operation status or result later. And then that'll be recorded in the caller's temporal service as the started event, and then returned back as operation started to the caller workflow. And if you're doing like a get execution info, that's when that feature will become unblocked. And then it'll surface here in the temporal UI as Nexus operation started, and just like pending activities, it'll show as a pending Nexus operation. And then some time will pass, and the Nexus operation will complete, and the callback registered on that handler workflow will be sent back to the caller's Nexus machinery, who will record that durably in the caller's workflow event history, and then return the operation result to the future that you're blocking on for the get operation to get the result for that. And it'll show that the handler callback has succeeded. And then in the caller, you'll see that the Nexus operation completed event is recorded there. So Nexus is GA. It's ready for both Go and Java production use cases, even with Java in public preview. That's basically 4 production use cases. There is formal support for that. And we're actively working on Python, TypeScript, .NET, the other SDKs. So I would love it if you joined us on the Nexus channel in the Temporal community Slack or over at the Nexus booth. And we'd love your feedback. Thanks. Q&A?
Yeah. How long do we have for questions? We have 11 minutes. Okay, cool. Yeah, who's first? Anything?
We can also take questions at the booth too.
Yeah.
Okay, yeah. The booth is a good. Oh, there's one hand. Let's just do that one.
Hi, thank you for the talk. At our company, we're looking into implementing like a multi-tenant architecture potentially, and would Nexus help with that, do you think?
Yeah, I mean, we can talk through some of the details there, but if you have a need to call into different, tenants, or you basically have multiple tenants calling you and you want to provide a shared service, this is a very common pattern, then you can make that available for others to use, either from temporal workflows. So if they're coming from, each tenant basically has their own namespace that they want to call from. And then also, once we support, the non-workflow callers, both through the Temporal SDK and through the HTTP gateway, that'll make it much easier for other tenants and even UIs and so forth to use Nexus directly. So yeah, definitely.